Hey guys, welcome to your Unit 9 Lesson 2 notes on families of quadratic functions. Remember that quadratic, just like the quad on campus, is a square, just like this totally obviously is a square. Yes, because when you have x times x inside, you get x squared. So quadratic functions begin with x squared. So if you have by the end of the day, you'll be able to identify characteristics of families of parabolas. Parabolas represent quadratic functions. A quadratic function will always take in the form y equals some number times x squared plus a different number times x plus another number. Y equals ax squared plus bx plus c. If you want to find the axis of symmetry, that's always going to be at x equals negative b over 2a. You can have a family of a function. Remember, families have something in common. They're related somehow because they have something in common. I'll say they have commonality, I guess. Okay, so if we look at these guys, what did these guys have in common? Well, you'll notice they all start at the same point. That point is called the vertex. So these guys always have the same vertex. Cool. What about these guys? They don't have the same vertex, but they're all aligned. They have the same axis of symmetry. And then finally, what did these guys have? Well, I don't know. What happens if we take one and we trace it and we just like move that to the other ones? Oh, that fits. Oh, that fits. Nice. But that does not fit. No, that doesn't fit these guys. Look, this one's way wider. This one's skinnier. That one's skinnier still. Cool. These guys have the same shape. They have the same thickness. They have the same width. These are all three different ways that families can form, that families of quadratic functions can form. Okay, I could go way into detail on how to form these, but I'm not gonna. Instead, I'm gonna just tell you what the shortcuts are. So, the way we talked about having the same shape, the way to change the shape is to change A. So if you change A, that means that the parabola gets skinnier. So as A gets bigger, the parabola gets skinnier. Okay, but if you change C, that means the graph will shift up. That's like our y-intercept. The graph shifts up. Now, if you have H, and so if you have some number inside the square, notice the square is outside of it, that means you're going to shift the graph not up that far, but that'll shift the graph left that far. Okay, so this makes your graph skinny. Changing A to be bigger makes your graph skinny. Changing C to be bigger means your graph shifts up. And changing H to be bigger makes your graph shift to the left. So I'm going to put like A, C, H here. Actually, no, I won't. I'm just going to leave them, and we can just keep referring. Okay. Now, those are the shortcuts. Guys, if you don't remember the shortcuts, you can always, 100% always, just make an XY graph, or XY table, and that's totally fine. If you forgot what parabolas look like and you just want to form an XY graph, that's fine. So for a normal parabola, let's get rid of this for a while. We plug in x. If we have y equals x squared, the 0 squared is 0. Yeah, that's as far as we can go. Let's do -3, -2, and -1 as well. So we get 1, 2 squared is 4, 3 squared is 9, -3 squared is 9, -2 squared is 4, and 1. So that would give us a parabola of over 0, over 4. Oh, that's way too high. Oh well. I didn't even do that right. Oink. Over 1 up 1, over 2 up 4. And you know what? If we went over 3, 1, 2, 3, we need to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So a normal parabola after making an XY table would look like this. Kind of. Please don't judge my art skills. But we don't have a normal parabola. Now we need to take our normal parabola and shift him down 2. Because what happens when we take our original graph and say, hey, just kidding, it's not x squared, it's x squared minus 2. Then I need to take each of these guys. Oh, 0 squared minus 2? I shouldn't have done that, should I? Okay. Minus 2, minus 2, minus 2, minus 2. If you want to go through and make all these in your XY table, that's fine. You would end up getting -2, -1, 2, 7, 7, 2, -1. Then after plugging all those guys into your graph, guess what happens? You get the same graph, except, ooh, that was not the same color, was it? That one. But he just goes down 2. So that's what our graph is going to look like. That -2 is like a, oh man, I did the whole thing wrong. That's a shift down. This all needs to be blue. Or I changed my mind. And now this can all be blue. Ha ha ha! Now they match. Okay. Crisis averted. Cool. So I'm going to show you the shortcuts in this video. If you just want to stick with your normal way of plugging them into XY table, go for it. That's great. But hey, look at this guy. Okay, so what do we have going on here? We've got a shift left 3. And we've got a shift up -1. Up -1 means down 1. So we can go left 3, down 1. That means we can take our original graph, and I had taken our original graph over here. But I'm going to get rid of the extra stuff. Bye. Now I've got my original guy. I'm going to take him and I'm going to duplicate him. I'm going to make him obviously new. I'm going to move him left 3. 1, 2, 3. And then I'm going to represent him with a shift. Oh, shooties McGooties. Okay. Now with a shift down 1. Okay. So our original guy, well, he's there. Okay. So we went left 3 by going 1, 2, 3. And then we went down 1 by going down 1 right there. And that's the graph we wanted. So if at the end we wanted to get rid of our extra stuff, we totally could. And we would be left with just this guy. But in your homework, I would prefer it if you left all your work in there, especially this, that, and these notes in here. Cool? Cool. Alrighty, for our last example, in a computer game, a player dodges the space shuttles that are shaped like parabolas. Look at those cool space shuttles. They're probably shooting lasers and stuff. Pew, 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 pew. Okay, anyway. The vertex of just one shuttle is at the origin. Nice. The shuttle's initial shape and position are given by the equation y equals 0.5x squared. That means this original guy is y equals 0.5x squared. That's how you design that space shuttle. It leaves the screen with its vertex at 6, 5. So it's a vertex right here. is a point over, nope, over 6 of 5. Find an equation to model the final shape and position of the shuttle. That means we're starting out with y equals 0.5 x squared. But how did we shift? Well, we shifted to the left. What color did I use? Blue. We shifted not to the left. We went over to the right 6. How do I make this an arrow again? Beautiful. Okay, well, anyway. We went to the right 6. That's what that 6 represented. And then we went up 5. Close enough. Good enough. That's what 5 represented. So we went right 6, up 5. Now, how can we make that change? If we want to go up 6, then we need to just add a 6 at the end. So we would do a plus 6. No, we won't, because we want to go up 5. Up 5. Okay. But now we want to shift not to the left, right. We want to go to the right 5. So that means we need to have a negative 5 inside of our square. So we need to crack open this square a second. I'm going to say not just x squared, but x and 5. But if we did plus 5, that would be going to the left. And we did not go to the left, did we? No, we went right. So that's a minus 5. Ta-da! But it's not 5, is it? It's 6. Man, I really kept messing up those numbers, didn't I? Okay. So looking at this tells us, hey, we squeezed our graph a little bit. Except we didn't, we unsqueezed it. We made it wider. So that made our graph thicker, wider. Sweet. And then this minus 6, that said, hey, move the graph right 6, rightio. And this plus 5, that said, hey, let's move this graph up 5. And guess what, guys? That's exactly what we did. Amazing. Cool. Those shortcuts will all be found right here. These are shortcuts to help you graph. You can always just make an XY table, and that's totally fine. That will always work as well. Whatever way you choose, I hope you have a fantastic time on your homework.